Hello everyone, I'm going to talk about the statistical literacy in this video. Statistical literacy is the ability of using quantitative skills within a particular context. This definition is based on the Holter's article. In the statistical literacy, we consider that what variables are measured and how they are measured, what technique they used, what statistics applied to analyze, and how the result is interpreted. These items considered in the statistical literacy. And also I'm going to talk about the differences between correlation and causation. In the correlation, we considered about the size and direction of relationship between two variables, but in the causation, we focus on the sequence of events. What event happened first and then which one happened the next. And also correlation provides us a linear relationship between two variables. But in the causation model, we focus on the causal relationship. In the correlation, X and Y has a relationship and they change each other definitely. But in the causation model, X makes Y. X creates Y. Without X variable, we cannot expect the Y variable. For example, when chocolate consumption rises between the women and the likelihood of the pregnancy is increases. This is the correlation model of the analysis. But in the causation model, gravity makes the fall down of the items. In this relationship, we are not talking about the mutual changes between two items. We consider about the sequence of the happening and then there is no mutual relationship. But in the example of the chocolate consumption and likelihood of pregnancy, they can change each other. In the correlation, we cannot talk about the assurance influence between two variables. We just expect and estimate the relationship between two variables. In the data literacy, several steps we need to apply to work with data. First, we need to access the raw data, and also we need to clean the data. We need to solve the missing data. We need to find the errors in data. After that, we need to create the new variables based on the raw data. Sometimes we need to standardize the data to create a comparative rate between the data. I'm going to use Excel here to analyze our data. Okay. Here I'm going to use COVID-19 data for the US counties. The data started from January 21st until September 24th. First, I need to filter the columns because I'm going to export data for specific counties. And I want to choose the Nevada and Clark County. Okay, the data for the Clark County started from March 5th until the September 24th. And then copy this data to the new sheet. I have almost 204 cases for the COVID-19 data in the Clark County. And also I'm going to bring another county. Okay, cancel the copy function. Okay. The next county that I'm going to bring is the King County, because this population between these two counties are similar, are close together. King County in the state of Washington. And then copy this data to our selected county sheet. Okay, and then copy. Also, you can change the color of these counties with different color. Okay. We bring the two counties here, Clark County and then King County in the state of Washington. And in the next step, we are going to use the T-statistic to compare the means between the COVID-19 cases. First of all, I need to create a new variable. In this data, we have a cumulative COVID-19 cases. We need to create a new variable. Okay. New cases. For this variable, I'm going to use the first one to start the second cell, and with comparing with the previous day, a day before, and then click on it. Okay, also you can check the data to be correct. 7 people for this day, 27 cases for this day, and then go up to end. Okay, we created a new variable here as a new cases of the COVID-19. And next variable I'm going to create, it is the rate based on the population. To create this variable, I'm going to divide each daily infected cases to the population. Estimated population for these two counties are 2.3 million for 2019, and I'm going to divide the daily infected cases to the 2.3. Okay, it means that for 1 million people there is a rate of infected COVID-19 cases for 1 million people, and then go up to the end. For example, in the King County, there was a new infected cases standardized by the population, 55 cases for 1 million population. Okay, this variable is a comparative variable between two counties. And I'm going to run the t-statistic for this variable to compare the average of COVID-19 infected daily cases for these two counties. For this end, I need to apply the t-statistic. I cannot show the data analysis tab here. I need to activate. To activate the data analysis, you need to go to the File and Options, and then go to the Add-ins and go to this section on the bottom and click on the Go, and then click on the Analysis Tool Pack, click, and then OK. Okay, I bring the data analysis tab here and then click on the data analysis. When you see this window, you can activate the t-test to sample assuming equal variances. Okay, before going ahead, you need to solve this problem. I need to edit this data because we cannot drag all formula to the all group. For this county, I need to bring from the 1. I need to edit manually and then go to the next step. I'm bringing the formula here. For the first variable, I need to choose the Clark County data. And then I need to choose the King County data. Okay. And then OK. We can see the t-test result here. Okay, to read this data, I need to change the format of the cell to the regular number and also match the other, this one too. Based on this result, our null hypothesis is rejected because the p-value is less than the 1%. Based on the decision rule, we can make a decision here. Our result is less than the 1% and our null hypothesis is rejected in this testing. Also, we can see the other statistic, like here in the Clark County, the average of the daily infected by the population for COVID-19 is 139 cases, but in the King County with the same population is 45 per cases. And also we can see the variances and also we can see the number of observations. In the King County, the COVID-19 cases started earlier than the Clark County, but the average of infected cases are more higher than the King County. Back to the PowerPoint here. We designed the null hypothesis as that there is no difference, the average of COVID-19 daily infected rate between Clark County and King County. But in the alternative hypothesis, we assume that there is a significant difference between the average of COVID-19 daily infected rate in Clark County and King County. Based on the result, we rejected the null hypothesis and accepted the alternative hypothesis. We need to interpret this result, that how we rejected the null hypothesis and confirmed the alternative hypothesis, and also you can justify by the other elements to interpret this result. Thank you for watching this video.